Greetings, my friend. Today I'll be teaching polymers, and I'm definitely sure that after watching this video, you won't forget that video and you won't forget the polymers. So, in our daily life, you have come across various things like toothbrush, then wool, socks, plastic bags. All are made up of the compounds known as polymers. Now, we know that like atom is the basic unit of the compounds. In a similar way, the polymers are formed by the simple structural unit, which are also known as monomers. Now let's go for the definition of the polymers. Polymers are the macromolecules which are made up of simple repeating units having unique properties. Depending upon the type of bond between the monomers. Now let us study them first, and then we will divide them upon the various bases. First we will study all the polymers, then in the next video I'll be explaining the bases on which we will categorize them. So first of all, to remember all of the polymers, you have to just remember only two of the polymers. First is polyethene, and one of the compound is buta-1,3-diene, which we will be studying afterwards. First, I'll explain the polyethene. So the first polymer is polyethene. Polyethene, which we generally use in our day-to-day life, it is made up of ethene, and then we will take as many as ethenes we can take, and then we will do the polymerization reaction in the presence of peroxide, and then the bonds, the double bond will break and it will form a chain of repeating units, and it is called polyethene. This is the part A because this polythene is also known as LDPE, that is low density polyethene. This low density polythene is mainly used for making plastic bags, then some plastic parts for the computer. And now in the same ethene we will do the polymerization reaction. We will do the same polymerization reaction in the presence of peroxide and another reagent that is known as Ziegler-Natta. That is Ziegler-Natta catalyst, which is TiCl4 titanium tetrachloride and Al(C2H5) thrice. This is our Ziegler-Natta catalyst, and it will form the same ethene in the same way. The way we form the polyethene of low density, it will form a polyethene which has a high density. And this is our HDPE, high density polythene. This polythene is used in making mailing envelopes. It is you have seen whenever you have ordered some products from the online, then the products generally come in a closed packing, and that packing is mostly of the plastic, and that plastic is also a high density polythene, so it is used in wrapping plastic. It is used as a wrapping plastic. Also, this polythene is also used in making plastic pipes. You just have to remember this monomer, because this is the monomer which we will be using to produce all other polymers in an easy way. Let us go for the another polymer, which is polyvinyl chloride, which you also know as PVC, polyvinyl chloride. Now, since I have told you, you just have to remember this one. So why I am emphasizing on this one? So let us understand that. So we have to take the same compound, which is CH2CH2. Now, instead of writing another H, we will add one other chlorine, because it is polyvinyl chloride. And the polymerization reaction is the same, and then we will take the N monomers, and then they will join to form the polymers. And this PVC, as you all know, is used in making pipes, baskets, etc. So now let's do the third polymer. The third polymer which we will be studying is polyacrylonitrile. Polyacrylonitrile. This polyacrylonitrile, shortly written as PAN, and also known as has this monomer with the cyanide group attached to it, and then we will do the same polymerization reaction to form our polymer. This polyacrylonitrile, it is basically used to form disposable Tupperware, that is disposable dinnerware, then cutlery, toys, etc. Then we will shift to another polymer, which is polystyrene. So basically you just have to remember these names, because it is polyacrylonitrile, which means nitrile group, polystyrene, which means styrene group, that is benzene. So we will form the polystyrene with the same monomer, that is ethene, but instead of writing the another H, we will write the benzene ring, and then it will go the polymerization reaction, and it will form polystyrene. Polystyrene, it is then let us shift to another polymer, which is polypropylene. Now polypropylene, CH2 again, then CH, leaving the another H. Instead of writing that H, we will write CH3, and then again it will go the polymerization reaction forming polypropylene. This is N. It means N number of propenes are connected to each other to form polypropylene. Now polypropylene, it is used to make ropes, then rugs, that is mats, then plastic parts of some toys. Plastic parts of toys. Now we will shift to another polymer, which is PMMA, known as polymethyl methacrylate, and this polymer, it is formed from this monomer and the same polymerization reaction, same n number of monomers joining to form the polymers. This polymer, it is used to make glass for windows, then the glass for aquariums. It is also used in dentures, then bone implants, etc. Now let us shift to another polymer, which is Teflon. Now instead of writing the H, we will write F. Teflon, CF2 double bond CF2. Now this polymer is formed in the presence of NH4 twice S2O, ammonium thiosulfate. Now this polymer is formed and it has fluorine bonds, and this polymer is used to make non-stick coatings for pans, and it also has various uses in making plastics. Now let us shift to another polymer, which is natural rubber. Natural rubber has a monomer, which I told you have to learn the buta-1,3-diene, so which we are using now, buta-1,3-diene, and then on the second carbon we will attach CH3, that is 2-methyl buta-1,3-diene. Now this polymer again has various uses because it's rubber, and this polymer, it has its uses, like more than 4,000 products are formed with the help of this polymer. This bond shifts here and here, this bond also shift here and here, and it forms CH3 double bond CH2N. More than 4,000 products are formed with the help of natural rubber. More than 4,000 products, like surgical gloves, aircrafts, etc. Now since it's natural, so we will induce some man-made changes and we will have synthetic rubber. Now synthetic rubber, same, it has the same monomer, but instead of CH3 now we will have chlorine. and it has a common name which is chloroprene. It basically comes in under the competitive exams. Under the competitive exams, it comes under the name of fluoroprene, and sometimes you have to identify the monomer, or sometimes you have to find the isomer, that the polymer which is formed with the help of fluoroprene as a monomer. This is neoprene. The chloroprene converts into neoprene. Remember this. These two are important names which comes under the competitive exam. Now, let us study another polymers. The another one is Nylon 66. The another one is Nylon 66. Now, the number 66 here has a significance. Now, what does this 6 signifies and what does this signifies? We will study now. This 6 signifies the hexamethylene diamide, that is NH2 CH2 6 NH2. This 6 means here we have 6 CH2 links. This 6 represents the number of carbons. This 6 represents the number of carbons. Also, this 6 represents the number of carbons. Now, this compound is reacted with adipic acid, which also has 6, that is 6 carbons, which is COOH, CH2, which is 4 times COOH. It is adipic acid. And then what will happen? It has 2 hydrogens. Let us write it here. This hydrogens attaches with the OH of the COOH group, and it will release water on polymerization reaction, and the remaining will form the polymer, which is NH, CH2 6, NH, C double bond O, CH2 4, C double bond O. Again, we will take N monomers to form a polymer, and this polymer, that is Nylon 66, it has high rigidity, due to which it is used in textiles. Sleeping bags that we mainly use for camping, sleeping bags, then tennis strings. Now we will come to another polymer, that is terylene. Now we will write the terylene, which is also known as Dacron, DACRON. Now you have to remember this polymer and also the monomers. The monomers here are very important because same type of monomers are used to produce another polymer. The first monomer is glycol. This glycol is added with terphthalic acid. It is terphthalic acid. In the similar way, in the presence of Sb2O3 and zinc acetate Zn O C double bond O CH3, that is the acetate group, zinc acetate. It will again release water and form the polymer CH2 O C double bond O C double bond O N. This is Dacron. This is used to make wraps for cushions. Then it is also used in thermoforming. FORMING. Now we will shift to another polymer, and it is glyptal. GLYPTAL. Now glyptal, as I told you, you have to remember these monomers because they are used to produce another polymer, and that polymer is glyptal. Now we have the same monomer here, that is glycol, CH2OH. It is added with, now it was tarthalic acid, and now we will use phthalic acid. Now it will again release water and form this is glyptal. Glyptal is used as cement. It is used in cements. Then it is used as a binding material. Also it is used for surface coatings. Now we will shift to another polymer, which is Buna N. The here N stands for the nitrile group. Now it's a shortcut to remember the monomers. Bu, that is buta-1,3-diene. Buta-1,3-diene. Then this buta-1,3-diene, it is, since I told you, the nitrile group which we had used in polyacrylonitrile. The monomer same, we will use here the same monomer with another monomer and combining to form the Buna N. Now they will attach themselves. It will form CH2, CH, double bond CH, CH2, again CH2, single bond CH, CN and N. This is Buna N. Now the Na here signifies that this reaction occurs in the presence of sodium. It is Buna N. Buna N is used as an adhesive. It is used as an adhesive. Then it is also used in rubber belts, shoe soles, etc. Now we will come to our next polymer, that is we are going to study our next polymer, which is Buna S. Now Buna S, again the Bu, it is for the buta 1,3-diene, CH2 double bond CH, single bond CH, double bond CH2. Na signifies that the reaction occurs in the presence of sodium. S signifies styrene. Styrene, that is the monomer which we had used in the formation of polystyrene polymer, and now we will use it again and combine it with the buta 1,3-diene to form another polymer which is Buna S. It occurs in the presence of sodium, some heat, then the monomer comes to form the polymer. Again the reaction occurs in the same way as before. CH, CH2, CH2, CH, N. This is used to form car tires. Then floor tiles. Also, this polymer has a common name which is SBR, that is styrene butadiene rubber. Common name SBR. It is also used by the competitive exams. Now we will study another polymer which is Bakelite. Now Bakelite, this polymer, it is formed with the help of phenol. I have indicated this hydrogen because it will help us to do the reaction, otherwise we do not write the hydrogens. It is reacted with formaldehyde in the presence of base. Now as we all know, in the presence of base, this converts into CH2OH, that is methanol group. Now this methanol will attach to this carbon, removing the hydrogen. That's why indicating the hydrogen helps us. Also it may attack this carbon, so it forms two products. One is ortho and one is para. CH2OH. Now if two orthos combine, if the combination is of ortho and ortho, if the orthos combine, then it produces Navolac. If the two orthos combine, then the compound formed is Navolac. Same, the hydrogen, they will release water. Doing the same polymerization reaction, CH2OH, CH2, it is Navolac. This is Navolac. Now if the ortho and para combines, then it forms the Bakelite, CH2OH, it forms Bakelite. and this is Bakelite. Now Bakelite is used to make firearms, then handles for the utensils, it is also used to make switches for electrical appliances. Now we will study another polymer, that is melamine formaldehyde. Melamine formaldehyde we will write the polymer. It has nitrogen on the place of carbon, 3 nitrogens and 3 carbons, then NH2. It reacts with again formaldehyde, the same type of reaction we had done, forming a compound NH2, NH, and then another, this group, it will attach on this hydrogen and forms CH2OH. Then this does the polymerization reaction NH2, NH, CH2, then it will attach. This will combine n times. It will form melamine formaldehyde resin. It is used to make decorative laminated panels. Decorative laminated panels. Now let us shift to another polymer, and that polymer is nylon 6, nylon 10. Nylon 6, nylon 10. Now this nylon 610, again, as I told you earlier, this 6 and 10 has a significance. The 6 and 10 refers to the number of carbon. Now same NH2, CH2 6 for the 6 number of carbons, that is the lower one, and for the higher one we will add the carboxylic acid group, adding 2 carboxylic acid group and the remaining 8 CH2. It is called sebacic acid. It will again release water on polymerization, forming nylon 6, nylon 10, CH2 8, C double bond O. Again we will take n monomers to form n polymers. Now this nylon 610, it is used to make bristles for brushes. Also we have different category for the nylon. First we had studied nylon 6, now we had studied nylon 610, and now we are going to study nylon 6. Now it has only one 6. It means it will be made with the help of only one monomer. Now that monomer is caprolactam. That monomer is caprolactam. 1, 2, 3, 4, 5 and 6 carbons, 1 nitrogen. Then this is caprolactam. This is caprolactam. In the presence of water, 1 OH group will attach with this one and H will attach with this nitrogen. It will form NH2, CH25, COOH. You can count the number of carbon. It will be 6 significant. So this 6 signifies the number of carbon. Again it signifies the number of carbon. Then it will form we will take N monomers forming the polymer nylon 6. This OH will attach on the another hydrogen of another monomer, and this hydrogen will attack on another OH of the another monomer. This is nylon 6 and this caprolactam. This caprolactam is formed with the help of hexane, and now this hexane transforms into this, and it has a different story which we will be discussing in another video. Comment if you want to know about that, how this caprolactam is formed with the help of hexane. Now we will be studying another polymer, that is PHBV. PHBV, it is a biodegradable polymer. This polymer, it is formed with the help of 3-hydroxybutanoic acid and 3-hydroxypentanoic acid. This is me drawing 3-hydroxybutanoic acid. Now I will draw the 3-hydroxypentanoic acid. 3-hydroxypentanoic acid. Again, it will remove water, forming the polymer CH, CH2, C double bond O, O, CH, CH2, C double bond O, CH2, CH2, CH3. It is used in specialty packing. It is used in orthopedic devices. ORTHOPHEDIC, orthopedic devices. It is used in controlled release of drugs. Controlled release of drugs. That is, you have seen the capsules. The colored capsule, this color is white and this color is red. It has some granules. Now this cover of this capsule is made up of PHBV, biodegradable polymer. We will study now another polymer, that is polyglycolic polylactic acid. Polyglycolic polylactic acid. This polymer, it is formed with the help of 2 monomers, which are this one and another one is OH, CH, C double bond OH, CH3. Again it will release water. Same polymerization reaction, giving rise to a polymer. It is also a biodegradable polymer and it has orthopedic uses. It is given in the NCERT. You can check it. PHBV orthopedic uses. Now we will jump on to another polymer. So another polymer is Nylon 2, Nylon 6. Same here, the 2 and 6 signifies the number of carbon. This is formed with the help of glycine, which is an amino acid which we will be studying in another chapter, in another video for the biomolecules. Glycine plus ammonium capric acid, NH2, CH25, COOH, that is amino capric acid. This polymer is formed with the help of two monomers. This polymer, it is used to make strings of musical instruments. Also, it is used in synthetic artificial fibers. Synthetic, THETIC, synthetic artificial fibers. Now we will study the last polymer, that is urea formaldehyde resin. Urea formaldehyde resin. This polymer, it is also given in the NCERT. This polymer is composed of two monomers, that is urea and formaldehyde. As the name suggests, urea formaldehyde. It forms NH, C double bond O, NH, CH2, N, taking N monomers, joining them and forming a polymer having N number of carbon, nitrogen, oxygen and hydrogen. It is used as a wood glue. It is used in decorative laminates. Also, it is used in wrinkle resistant fabrics. Now this is all for this video. Thanks for watching and don't forget to subscribe and like my channel.